Hello everyone. Today's problem is LeetCode 515. Find largest value in each tree row. So here we are given a root of a binary tree. We have to return an array of the largest value in each row of the tree. So here is an example. This is given as the root is 1. In the next level we have 3 and 2, and the child are 5, 3 and 9. So here we can see the output is 1, 3 and 9. In these types of problems we can use BFS, which will deal with the rows or levels of a binary tree. With BFS we can handle one row of the tree at a time. So in that case, say here on the first traversal, BFS will traverse the node 1 with value 1. So here there is only one value, so we will have 1, that is the largest value in this row. The next one we have 3 and 2, so out of that 3 is the largest, and the last row is 5, 3, 9. This is the largest value. We can use a priority queue, a heap for each row, and then the max value will be on the top of the heap. Now we are going straight into the coding. So here we will check if the root is null of the tree. In that case we will just return the empty list. This is the base case. Now we have to initialize a vector or array which will keep the result, and then we'll call a BFS function. In the BFS function we'll send the root node and this result vector, and it will be just returned. We are still writing the BFS code. So the first parameter is the tree node, that is the node that is sent from the main code, and the second parameter will be the vector where we will store the result. Now in case of BFS we know we have to use a queue. The queue will be of type the tree node, and we will push this node into the queue. This will be the source node. Now we will need some more variables like queue size, and also we have to count the number of variables, how many elements are there in each row. Now we'll just check if we have checked all the variables. Before that we have to check if the queue is empty for BFS traversal, and we will keep a priority queue. You can also use just a maximum value. Here we're just keeping it as a priority queue. In that case we don't need to add any logic. The priority queue is the heap that will keep the highest value at its top. Now we have to traverse the array, the row. So for each row we know that count is the number of elements we have traversed, we have calculated, and queue size is the size of the queue. Now in a temporary node we will keep the queue front node and we'll pop it, and we'll check if we'll push the value in a heap. So the heap will calculate the highest, the maximum value. It will keep at its top. That's the basic property of a heap. Now we'll check if the left node is not null. In that case, we'll push that into the queue. That's the basic BFS. In case of right node, we'll check the same. We'll check the null, and then if it's not null, we'll push in the queue. Now this loop is finished. So this is the inside while. This is ends, which will calculate all the row calculations. Now we'll check if the heap size is not empty. We don't need to, the size is actually an integer, so we can check that. In that case, we will just push back the top of the heap, and it will be kept in the result. Now we are running this. You can see the test cases are passed. Now we will submit the code. As you can see, this is accepted. Then you can check the time complexity and the space complexity of the code. Here you can improve it by removing the heap and use a max value for each row.
We are going to solve LeetCode number 230, kth smallest element in a BST. We are given a root of a binary search tree and an integer k. We have to return the kth smallest value of all the values of the nodes in the tree. So in case of BST, we know that the the value in the root will always be greater than the value of its left child, and the right child will always have a greater value than the root value. So we know that in case of in-order traversal, we will always get a sorted array in case of a BST. This is the property of BST. So from this tree, you can see that from this root we will come to the left side. There is no other left child, so we'll start from here 1, then we'll get 2. There is no other child here. Then we'll go back to the root 3, and then there we will come back to 4. So the values will be 1, 2, 3, 4. So in case k is equals to 1, we can return the value 1. Now another example, in this tree, if we use the in-order traversal, we will get 1, 2, 3, 4, 5, 6. So you can see this is a sorted array, and we'll always have the sorted values in case of in-order traversal in a binary search tree. So the output will be 3 because we need to get the kth smallest element of the BST. Here the number of values of k is given at most 10 to the power 4, and the node values could be always positive, and the highest value could be 10 to the power 4. Now we are going to code this. Now we are going to start coding. The idea is to build an in-order traversal of BST. In that case, the arrays will be sorted. So we'll need a factor which will keep all the values in the ordered list. Then we'll call a function. We'll implement the function a bit later. We'll put the method parameters, the function parameters. For this function, we are going to need the node, one node, the root node, and also the list, the vector list that will keep the values in sorted order. In case of this traversal, in-order traversal, we'll get the sorted array in ascending order. So in that case, we can return the value as k minus 1th element of this array. That will be the answer. So now we are going to implement the recursive function for in-order traversal in the BST. So this is the base case. In case the tree node is null, we'll return, as this is a void as a return value, so we'll not return anything. Now we have to call the left subtree in case of in-order traversal. So the first parameter will be the left node, and in-order list, that will be always as a parameter. Now we are going to add the value of this node into the in-order list, and then we are going to call the right subtree using the right node of the tree. We are running the code, it's showing accepted. Now you can see we are submitting the code, it's showing accepted. You have to know the time complexity now. This is order of n for time complexity, and memory space complexity is also order of n. Now the previous recursive solution we are going to try to implement in iterative solution. So here we are going to use stack. There we used recursion. Here we will use stack. This way we can speed up the solution because there is no need to build the entire in-order traversal tree, and we could stop after the kth element. We have to traverse the left subtree first, so we are going to check if the root node is not null, and then we have to push the left subtree, the left node of this node into the stack. So thus the left subtree traversal will be completed. Now we are going to take the root node and from the stack top, and we will pop it from the stack, and then we have to check if this is the kth value. In that case, we will return the value of the node. Now we will do the right traversal. So the right right child of the node will be used as the next node. This is accepted. Now we are going to submit the code. It shows accepted. The runtime complexity in most cases is order of n, and space complexity is also order of n.